Every 30 minutes, a healthy node was marked dead, triggering a rebalance storm that spiked latency to 10 seconds. The root cause? A 2-second JVM GC pause caused 3 consecutive missed heartbeats against a fixed 5-second timeout. The node was healthy, just paused. Here's exactly why. Let's start with the basics of heartbeats and failure detection. Welcome to TheCodeForge. Before we dig into that production issue, let's cover heartbeats and failure detection. Heartbeats are periodic signals sent between nodes to prove liveness. Failure detection uses the absence of heartbeats to declare a node dead. It's the pulse check of distributed systems. Without heartbeats, a node crashes silently. Your load balancer keeps sending requests to a black hole. TCP keep-alives take 2 hours by default. Heartbeats give you control over detection speed. Every 5 seconds, a UDP packet is sent to monitor. Local, 9,999, with the string, alive 12,345. Use UDP for heartbeats to avoid TCP backpressure. The simplest failure detection: if no heartbeat for n seconds, declare dead. But n is a minefield. Too small gives false positives from GC or network jitter. Too large delays recovery. The phi-accrual failure detector models heartbeat arrival times as a normal distribution. It computes a suspicion level phi. When phi exceeds a threshold, you act. This adapts to network behavior. All-to-all heartbeats with 1,000 nodes means 1 million messages per second. Gossip protocols like SWIM solve this. Each node periodically picks a random peer and exchanges membership. Failure detection is piggybacked. SWIM's indirect probe prevents false positives from asymmetric network partitions. If a can't reach B, I ask C and D to ping B. If either succeeds, B is alive. If a network partition splits your cluster, both sides think the other is dead. Both start serving writes. When the partition heals, you have conflicting data. Heartbeats alone cannot solve this. In a 3-node cluster, require 2 nodes to agree on a leader. If a node can't reach the majority, it must step down. Never trust a single heartbeat timeout for consistency. Rule of thumb: set heartbeat interval to 1/3 of the desired detection time. For a 15-second detection, heartbeat every 5 seconds. With adaptive detection, set the suspicion threshold instead. Always add jitter. Without jitter, all nodes heartbeat at the same time, causing a spike in CPU and network. Add plus or minus 10% jitter to spread the load. This is critical when nodes restart simultaneously. You need to monitor heartbeats themselves. Track heartbeat arrival jitter, missed heartbeats per minute, phi values over time. A sudden increase in jitter often precedes a node failure. These commands count heartbeats per node and detect gaps longer than 10 seconds. Use them to identify nodes that are missing heartbeats. Heartbeats are overkill for 2-node systems. Just use TCP keep-alives with a short timeout. For extremely unreliable networks, use a circuit breaker pattern instead. This is the same issue we highlighted at the start. Here's exactly why that happened. The node was healthy, but a JVM GC pause of 2 seconds caused 3 consecutive missed heartbeats. With a fixed 5-second timeout, the monitor declared the node dead, triggering a rebalance storm that spiked latency to 10 seconds. The fix was to change to a phi-accrual failure detector with suspicion threshold 8. The adaptive algorithm accounts for historical variance, so a 2-second pause doesn't trigger a false positive. Also tuned GC to reduce pause duration. A fixed timeout doesn't account for transient pauses like GC. A 2-second pause can cause 3 missed heartbeats and a false positive. Always use adaptive detection like phi-accrual. This is the exact mistake from the incident. A fixed timeout doesn't adapt to transient pauses. Always use adaptive failure detection that accounts for GC pauses and network jitter. I've seen a startup's distributed lock service use heartbeats to decide leadership. A 2-second network blip caused both nodes to think they were leaders. Both wrote to the same file. Corruption: always pair heartbeats with a quorum-based lease. If your heartbeat sender shares a thread pool with request handling, a traffic spike can starve the heartbeat thread. Fix: dedicate a separate thread pool for heartbeats with a small queue and discard policy. If the heartbeat sender's clock jumps forward, the failure detector may falsely suspect the node. Mitigate by using a monotonic clock, e.g., time monotonic, in Python, instead of wall clock, and clamp the recorded interval to a maximum, e.g., 2x expected interval, to prevent a single clock jump from skewing the history. Heartbeats are overkill for two-node systems. Just use TCP keepalives with a short timeout, e.g., TCP keepitl equals 5, TCP keepinful equals 1, TCP keepint equals 3 for tilde-8's detection. For extremely unreliable networks, e.g., satellite links, heartbeats cause constant false positives. Use a circuit breaker pattern instead. A common production bug is heartbeat thread starvation when the sender shares a thread pool with request handling. Dedicate a separate thread pool for heartbeats with a small queue and a discard policy. Missing a heartbeat is better than blocking. If a node is falsely marked dead, first check GC logs for pause duration. Increase phi threshold to 12. Reduce GC pause target with XX, max GC pause millis equals 200. If using fixed timeout, switch to adaptive. Let's run through some common interview questions. How does phi-accrual handle increased latency? It adapts. Mean and variance increase, so phi for a given elapsed time decreases, preventing false positives. When choose gossip over all-to-all, when cluster 100 nodes. Gossip is O n log n, all-to-all O n2. What if heartbeat sender's clock jumps? Use monotonic clock system nanotime, and clamp recorded interval to max 2x expected. And a few frequently asked questions. What is a heartbeat? A periodic signal indicating the sender is alive. Difference between heartbeat and keepalive. Heartbeat is application level, keepalive is transport level. Heartbeats give control over frequency and can detect application hangs. How to choose heartbeat interval? Start with 1/3 of desired detection time, add plus or minus 10% jitter. Heartbeats are the pulse of a distributed system. Get them wrong and your system becomes fragile. Fixed timeouts are a trap. Always use adaptive failure detection. Gossip protocols scale, and heartbeats alone cannot prevent split brain. Always pair with a quorum or lease. Ready to go deeper? Up next, publish subscribe pattern, then Kafka and the distributed log, then MapReduce and batch processing. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.